This is your fourth 9 weeks benchmark review. I'm going to start with question 6, the first one where you have to start doing some number crunching. Okay, you can look where I posted the full solutions for the answers for 1 through 5. Number 6, the thing you have to remember is that all exterior angles add up to 360 and that each exterior angle is the same measure. So that's like taking, for instance, on number 6, it has 7 sides, therefore it's going to have 7 exterior angles. And I'm taking that full 360 degrees and I'm slicing it up 7 equal ways. So if I do 360 divided by 7, I round that off, I get that the answer is 51.4 degrees. Number 7. I'm going to approach it the same exact way. I'm going to do 360 degrees. I'm going to divide that by 9, and I get that my answer is 40 degrees. Number 8, approaching that the same way. I have 5 sides, therefore I have 5 exterior angles. 360 degrees divided by 5, you get that your answer is 72 degrees. Number 9. Number 9, that set starts inscribed angles, and you have to remember the property associated with that. If you look at number 9, the angle that involves the arc, okay, you need to find where that is. Just follow the rays out to your circle until you find it. You get that the arc is 104, and the property says that that angle is half that. So I take 104 degrees, cut that in half, and I get that my answer is 52 degrees. Number 10. Again, you may want to look at my solutions where I say a little bit more. I write down a little bit more than what I'm going to say. But in order to get to that answer, I'm going to take 112 degrees, multiply by 2, and get the answer is 224. Number 11. Again, I'm going to take 102, number 11, cut that in half, okay, and I get that my answer is 51 degrees. Number 12, the first thing I got to do on number 12 is realize that I need arc GH. So the measure of arc GH is going to be 61 times 2, which is 122 degrees. The second thing that I've got to do on that problem is the measure of arc FH is equal to 360 minus 104 minus 122 is equal to 134 degrees, and that winds up being my answer. Number 13. Number 13, you must know angle property for 2 secants. It says that I take the larger arc minus the smaller one, and half of that number is my answer for that angle. So looking at number 13, the measure of angle K is going to be equal to 164 minus 74, all divided by 2. If you do that, you get that your answer is 45 degrees. Number 14. Again, I'm going to follow the property. The measure of angle R is equal to 175 minus, we don't know that small arc, so I'm going to put it as x over 2. I do know that the measure of angle R is 55, so I'm going to plug that in. And now I'm going to solve this equation. The first thing I'm going to do is multiply both sides by 2. In doing that, I get 110 equal to 175 minus x. I'm going to subtract 175 from both sides. After doing that, I get negative 65 equal to negative x. Divide both sides by negative 1. I get that x is equal to 65 on that problem. And that's answer choice C. Number 15. Number 15, I have to know a property that says opposite angles in a quadrilateral are supplementary. Alright? So I'm going to use my answers to my advantage in this particular problem. So first I'm going to set up the two equations that I've got. So the first one I'm going to set up is 10x minus 7 plus 18y plus 7 equal to 180. The next one I'm going to set up is 18y minus 3, that's one angle, plus 9x plus 12 equal to 180. Now I'm just going to use my answer choices to see which one works. And if you try and keep plugging in, you find out that it's D. D says that my x is 9 and my y is 5. So again, I'm just going to do A for example. I would plug in my x of 9 minus 7 plus 18 times 5 plus 7. And the question is, does it equal 180? The answer is yes. You do the same thing. Plug it in down here. 18 times 5 minus 3 plus 9 times 9 plus 12. The answer, does that equal 180? Yes, it does. So D is my correct answer. And you can just punch all this in your calculator and see, does it equal 180? Number 16. Number 16 is a property as well. I have a tangent and secant line meeting. The property says I can take and again you can look at my solutions for this and see how the property folds out. I'm just going to start with the numbers. So 10, I'm going to start with x squared equals 8 times 18. Doing that, I'm going to get x squared equal 144. To solve it, I'm going to take the square root of both sides. X equals 12. Number 17. Number 17, same property. X squared equals 4 times the length of the entire thing is 9. X squared equals 36. Take the square root of both sides and get x equal to 6. Number 18. Same property yet again. 6 squared equal to x times x plus 5. I get 36 on the left equal to distribute the x through. X times x is x squared. X times 5 is 5x. I want to get this thing equal to 0. I'm going to subtract 36 from both sides. I get 0 equal x squared plus 5x minus 36. Now from here, if you remember how to factor, you can do that. Or you can use your polynomial tool on your calculator to get the answer. You're going to get two answers on this one. X equal to negative 9 and x equal to 4. Both are fine answers, but since our numbers are attached to a length, it can't be negative 9 because I can't have a negative length of anything. So the best answer, the correct one for me, is I'm going to take 4. And 4 is the correct answer. Number 19. Number 19, and again, I think I'm just going to do 19. 20 and 21 are work the same way. I start out with the area of a sector. So a portion of the circle, theta, remember theta is my central angle. Sometimes it'll be given to you like it was on these problems, or they'll say your circle is sliced up different ways. You would just take 360 divided by how many ways it's sliced up to get your central angle. Times r squared. So in this particular problem on 19, my theta is 300 pi over 360 times my radius they give to me is 2 squared. Equal. Now if I look down at my answer choices, since pi is just hanging out, okay, they're not going to multiply through, I'm just going to take this thing out till the end. So now I've got 300 times, I'm going to go ahead and do 2 squared is 4 over 360. If I use my Inspire to let it reduce that fraction for me, I get 10/3, and I just remember I have to put pi back. And it winds up being inches squared for my units. Again, 20 and 21 is the same way. You're just changing your theta and your radius. Number 22, that's the area of a square. So the way I give it to you, in that side squared, I give you one side, plug it in, 2 squared, you wind up getting 4 meters squared for the area. Keep in mind, if I were to give you a square, all right, and gave you a diagonal, I told you, for example, that diagonal was 10. You need to realize that the sides in the triangle are all the same numbers, so I could use x and x. And I could, at this point, use Pythagorean theorem to get me what that x is. Okay. So just keep that in mind. So again, don't forget Pythagorean theorem. I know it's been a while since we've used it. Okay. Next problem. 23, central angle properties. For that one, 23, 24, and 25, I think it's best to just look at my solutions. 26, 27, 28, 29, same thing. 30, those volume problems you're just plugging in. If y'all still have more questions, just message me. I'll be happy to help. I do wanted to make sure that I got 33 in this video for you. 33 is a composite figure, which means it's made up of other figures that we actually know how to find the area of. So doing that, looking at it left to right, I've got a semicircle, a rectangle, and a triangle. Now the directions say find the area of this entire figure. But what I'm going to do is split it up into these 3 shapes, find the area of each individual shape, and then add the total together. So a semicircle here, a normal circle is pi r squared. But since it's a semicircle, it's half of it, so I'm only going to take half the area. The radius is going to be 3. I had to take 6 and cut it in half. 3 squared over 2. I want to leave it 9 pi over 2 until the end. Remember, I don't want to round to my final answer. The rectangle is length times width, so I wind up getting 10 for my length, 6 for my width, so I get 60 here. The triangle is 1/2 base times height, so that's equal to 1/2. The base, if you look at the segment in the top segment, the bottom and the top, you've got 14 and you've got 10. If you subtract those out, you'll get just that piece that has the triangle base on it, and it's 4. The height on that triangle, look at different sides of that rectangle, it's going to be 6. If you multiply that all the way through, you get 12. So if you add all this up in your Inspire, you've got 9 pi over 2 plus 60 plus 12. Rounding to the 10th place, you should get 86.1 square inches. In 34, we spoke about in class today. Just remember, if you have that regular polygon inside of a circle and you know the side length, that's also your radius. So on 34, it looks like a more difficult problem than it actually is. They're giving you your radius. It's that property about polygons inside of a circle. So pi times the radius would be 5 squared. So you wind up getting, rounding to the 10th place, 78.5 units squared. Right. And again, make sure you don't just look at this video, because I left some of the ones that you didn't have to do a lot of work out. Make sure you look at the paper solutions that are attached to this post also.